to the next session on Advanced MATLAB. In this session, we will discuss as to how calculus can be done in MATLAB. MATLAB provides various ways for solving problems of differential and integral calculus, solving differential equations of any degree, and calculation of limits. Best of all, you can easily plot the graphs of complex functions and check maxima, minima, and other stationary points on a graph by solving the original function as well as its derivative. Calculating limits. MATLAB provides the limit function for calculating limits. In its most basic form, the limit function takes expression as an argument and finds the limit of the expression as the independent variable goes to 0. For example, let us calculate the limit of a function f of x is equal to x cube plus 5 divided by x raised to 4 plus 7 as x tends to 0. So as x is tending to 0, if I substitute x as 0, I will get the answer directly as 5 by 7. So when I have to write in MATLAB, I'll first declare the variable x as SYMSX, and then I'll write this equation over here and I'll use the function limit. Now here you can add a comma and a 0, which means the limit is tending to 0. But if you don't write anything, MATLAB will assume it as 0 itself. So let us take this function to MATLAB. So you can see the answer is 5 by 7. The limit function falls in the realm of symbolic computing. You need to use the SYMS function to tell MATLAB which symbolic variables you are using. You can also compute limit of a function as the variable tends to some number other than 0. To calculate limit x tends to a, f of x, we use the limit command with arguments. The first being the expression and the second is the number. As we saw here, first is the expression and then you can associate a number over here. That x approaches, here it is a. For example, let us calculate limit of a function f of x is equal to x minus 3 upon x minus 1 as x tends to 1. So mathematically when you solve, you will substitute x as 1. So it will be 1 minus 3 upon 1 minus 1, which will be 0. So when the denominator becomes 0, this function is not going to be defined. So I'm going to write in this form limit x minus 3 upon x minus 1 and x is tending towards 1. So let's substitute this in MATLAB. So you can see here you get NaN, which means not a number because it is infinite. Any number upon 0 is infinite. Now let me write the same function. And instead of 1, I'll write this as 0. I'll save it as A1. So when I run this function now A1, this is not defined because I have not defined the variable x. In MATLAB, by default, the variable is assumed to be x. Hence, when I was directly writing this equation, it was not required to declare the variable. Here, I'll have to declare it. So I'll just run the program once again. I get the answer as 3 when x is 0. So you can see 0 minus 3 is minus 3 and 0 minus 1 is minus 1. So what remains is only 3. But when I put this as 1, this will be not a number because it is a number divided by 0, which is infinite. The next example is limit x square plus 5 and the x is tending towards 3. So let me take this in MATLAB. Since x is 3, 3 square is 9, 9 plus 5 is 14. You can change this by changing the limit. Say you can write this as minus 5. Minus 5 square is 25 plus 5 is 30. Next, we'll talk about verification of basic properties of limits. Algebraic limit theorem provides some basic properties of limits. These are as follows. The first one is limit x tends to p. Now this is tending to p, it can tend to any number or any variable f of x plus g of x. So when I have to give this limit to both of these functions, I can separately write them and addition sign can be put in between. So it is limit x tends to p f of x plus limit x tends to p g of x. The next one is limit x tends to p f of x minus g of x. Now again, if I have to segregate these two, it will be limit x tends to p f of x minus limit x tends to p g of x. Next, limit x tends to p f of x into g of x. Here also again you can segregate both of them by giving limits to each of them and a multiplication sign in between. And the last one is limit x tends to p f of x divided by g of x. Again, if I have to assign limits to both, it will be limit x tends to p f of x upon limit x tends to p g of x. Now we will verify these by considering some example. Let us consider two functions. F of x is 3x plus 5 upon x minus 3 and g of x is x squared plus 1. Let us calculate the limits of the function as x tends to 4 of both functions and verify the basic properties of limits using these two functions and MATLAB. So first we will write the script as symsx, that is a variable. Then f is equal to 3x plus 5 upon x minus 3, this is the equation, and g is x squared plus 1. The first thing that I'll write is L1 is limit f comma 4, which means in this function I will substitute x as 4. Then L2 is limit g comma 4, means I'll substitute 4 in this equation in place of x. Next I am going to add the limit. So this is limit f plus g comma 4. Then I have L subtraction sum is equal to limit f minus g comma 4. Then you have L multiplication is equal to limit f into g comma 4, and for division it will be limit f upon g comma 4. Now let's solve this in MATLAB and see how do we get the results. I'll open a new script and I'll save it. I'll say A2. I'll run A2 now. So you can see here these values. For the first one, when I substitute x is 4, 3 into 4 is 12, 12 plus 5 is 17 and 4 minus 3 is 1. So the answer should be 17 upon 1, that is 17. For g, when I solve, this will be 4 square plus 1. So it is 17 again. So these two are calculating the value of the function. The third one is doing the addition of f and g. The first value I got as 17 and for g also I got the value as 17. So when I add 17 plus 17 is 34. When I subtract 17 minus 17 is 0. So you can see here 0. Then I have multiplication. So it is 17 into 17 is 289 and last is division. So it will be 17 upon 17, that will be 1. So these are the values that you have got. Now suppose if I change this, instead of 4, I write this as minus 4 and solve once again. So these are the answers that I get. For L1 I get 1, L2 I am getting 17, when I add it will be 18, when I subtract it is minus 16, on multiplication 1 into 17 is 17 and division is 1 upon 17. So that's how you get these values. And also we verify these equations using MATLAB. Next we'll talk about left and right sided limits. When a function has a discontinuity for some particular value of the variable, the limit does not exist at that point. This is something which we already know from mathematics. In other words, limits of a function fx has discontinuity at x is equal to a when the value of limit as x approaches x from left side does not equal the value of the limit as x approaches from the right side. So when you approach from the left side, you get a different value. When you approach from the right side, you get a different value. This leads to the concept of left-handed and right-handed limits. A left-handed limit is defined as a limit as x tends to a from the left, that is, x approaches a, for values of x less than a. So you must have seen in mathematics, we generally represent this as x tends to a and a minus sign here. And for the right-handed limit, it is defined as a limit as x tends to a from the right, that is, x approaches a, for values of x greater than a. So here when I write in mathematics, it will be x tends to a plus. When the left-handed limit and right-handed limit are not equal, the limit does not exist. So this is called as discontinuity in a function. Let us consider a function f of x is equal to x minus 3 upon mod of x minus 3. We will show that limit x tends to 3, f of x does not exist. MATLAB helps us to establish this fact in two ways: by plotting the graph of the function and showing the discontinuity, by computing the limits and showing that both are different. So we will calculate the values in one way, and in the other way we will draw a graph. The left-handed and right-handed limits are computed by passing the character strings left and right. You can see here in single inverted commas you have to write left and right to the limit command as the last argument. Let's take an example. We'll first define the variable x. The function is x minus 3 upon absolute x minus 3 because it was in mod sign. EZ plot. This is used to plot the graph. F is the function and you're plotting from minus 5 to 5, that is the range given. L is equal to limit f comma x comma 3, which means x is tending to 3 from the left. R is equal to limit for the function x is tending to 3 from the right. So let's plot this in MATLAB and also calculate the value. When you run it in MATLAB, you will first get the graph and then you will see the value that is obtained. I'll save this as A3. So the graph is obtained first and then we got these values. L is minus 1 and R is plus 1. You can see here it is from minus 5 to 5, the value of x. So that's all about calculus which is used in MATLAB. These are the very basics that are required to be understood in mathematics, and how do you solve in MATLAB is explained through this session. So with this I end the session. I hope you have understood MATLAB calculus. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.